You've seen how to add, subtract, and multiply rational numbers. In this video, we extend into dividing rational numbers. Let's start with an example. There are 9.5 pizzas being divided among 3 classrooms. How many pizzas does each classroom get? How do you know the result is a rational number? Here is the division expression for finding the fraction of a pizza each classroom gets. Notice that the numerator is a decimal, not an integer. This expression doesn't look like a rational number, yet it is. Let's rewrite the numerator as a mixed number, as shown here. The numerator is still not an integer, so let's rewrite it as an improper fraction. Here, the numerator is an improper fraction, but it is in a form that we can now rewrite it, as shown here. And we get 19 over 6. In this form, it is the ratio of 2 integers, and you can now see that the original expression is, in fact, a rational number. If we treat this ratio as an improper fraction and rewrite it as a mixed number, we get 3 1/6. This is the amount of pizza that each class will get. This is an example of a rational number division expression resulting in a rational number. Let's look at another example. How can you show that this expression is a rational number? Write the result as a ratio, mixed number, and decimal. This is a ratio of 2 rational numbers, but neither term is an integer. But we can change that. Multiply the top and bottom by 10 to get this term. The numerator now has an integer term, but the denominator doesn't. Multiply the top and bottom by 10 to get this term. This has an integer in both the numerator and denominator and looks like the standard definition of a rational number. The ratio of 2 integers, the denominator not being 0. We can simplify this term to get this. We can simplify further by dividing out the negatives to get this term. This is the rational number in simplest form, written as an improper fraction. This is the rational number, written as a mixed number. And here is the rational number written as a decimal. Let's look at a final example. If you divide one rational number into another, is the result always a rational number? Why or why not? Let's start with this expression a divided by b. Even though each term is a rational number, it's clear that b cannot be 0. Otherwise, there would be a 0 in the denominator, which is undefined. Each term in this expression is a rational number, so using the definition of a rational number, we can write a over b here, where a and b are integers and b is non-zero. And we can write c over d here, where c and d are integers and d is non-zero. Also, in this case, c itself can't be 0, because the entire denominator can't be 0. This expression is one fraction divided by another fraction. This can be rewritten as a multiplication statement, where a over b is multiplied by the reciprocal of this term, as shown here. The expression then becomes AD over BC. Each term is the product of 2 integers, and the product of 2 integers is another integer. So we have the ratio of 2 integers. Furthermore, we know that b here cannot be 0 because it was the denominator of this term. And recall, we determined that c couldn't be 0 either. This means that the entire denominator cannot be 0. And so this expression is, by definition, a rational number.